Alexandros, thank you so much for taking the time to speak with me about neuroaesthetics and architecture.
Thank you so much for the invitation.
So, you are a neuroscientist, you are not
Yeah.
an architect, yet you are fascinated by fractals and geometry and architecture. Like, first of all, why did you get into this interest of architecture? What spurred you? And then also, if you could introduce yourself so we know the full range of what it is you do.
Yeah, it's a complicated story. So yeah, I'm a neuroscientist. When I was doing my PhD at UCL with Professor Parnavellas, a great lab, I was working on developmental neuroscience at the neuroanatomical level. There at the same time, one of my professors was Semir Zeki, who was the founder of Neuroaesthetics. So my interest in these things dates back to that time, but it's not something I followed for a number of years. So my work was purely anatomical, microscopical. Then at some point I met with Professor Nikos Salingaros, a mathematician and architectural theorist from the University of Texas, San Antonio. And he has approached these things from a scientific perspective, the issue of architectural beauty and its connection to well-being, since many years, I would say before most neuroscientists thought about these things. And this contact, or now friends and collaborators, sort of made me go in this direction. And I would say also in this direction because it's gone in parallel. My main affiliation is at URAC Research in Bolzano. I'm the imaging lead here, and I work in projects related to disease and things like that. At the same time, in parallel, through external collaborations mostly, for example, mainly with the Human Architecture and Planning Institute in Boston and other people, I'm working on research related to architecture. And this is why once somebody wrote an email to me to invite me to a meeting related to neuroarchitecture. And he said, I wasn't sure if you're one person or two because I see two streaks of publications that have nothing to do with each other. Well, I think I need a clone, but anyway.
Well, this is why we need interdisciplinary research.
Yeah, I agree. I think a few strange people like me are useful. I mean, if everybody was like that, it would be a bit too complicated. But a few people with sort of convoluted interests are useful because they can help with the cross-pollination, I think.
Also move the fields forward, because if we didn't have that, we're not going to have new fields. We're not going to have new areas of inquiry. It's just going to be the same stuff.
Yeah,
So I
yeah,
am
yeah, yeah.
grateful for you, and I look forward to seeing how you, from a neuroscientist perspective, are looking at architecture, what your research has found, and also I know you're an expert on fractals and complex geometry, and I can't wait to hear how you've done this research on our brain and like what it looks like and all of that.
And one thing I want to add is that I come from an artistic family of classical musicians, so I was interested in the arts, generally speaking, since a very young age, and in aesthetics, and so it all came together in a way.
That's
Okay,
so
so
cool.
I will say a few things about my work and also the work of others because it's each of us just puts a little bit of
Hmm.
a little contribution, sort
Hmm.
of in the big picture. So I'm starting with this image, and I often,
Hmm.
I've shown this a couple of times before presentations, and I ask people which one is prettier, and I think most people would argue it's the one on the left. And then I go to this one, and and here's where people laugh. But I mean, and Kant is not in the competition. But I have a reason why I'm showing these two images. Well, the snake. The third is about the snake. What I want to get across is that our reactions to our environment do not come as a result of carefully analyzing the environment in a logical way and deciding how to react. It's quite the opposite. So it's been discovered. Well, this scary diagram shows basically the pathway of vision. So you have the retina, the photosensitive part at the back of the eyes, And then you get these processes going into the thalamus, which is the relay station. And from there, most of them to the visual cortex, where you have conscious vision and its various parts, color, movement, etc. But also to some other areas. One of them, labeled as C there, is the suprachiasmatic nucleus, which is a remnant of older evolutionary stages. And in us, what it does is that it helps us, well, it prompts us to turn our head, our attention to movement from the side, so to something that is potentially threatening. And more interestingly, in this diagram, there is this part of the thalamus called the pulvinar, which recognizes snakes. And upon detecting something that looks
Only
like a snake,
snakes.
yeah, well, I presume that it can get confused by things that look like snakes because I've seen these YouTube videos with cats freaking out with cucumbers. So I'm assuming that they're probably not that, but I have no
So we
scientific
have
data on that.
a snake detector thing in our head.
We have a snake detector thing in our head. This
Okay.
sends a message directly to the amygdala, which causes us to be afraid. Um, So we are afraid of the snake before consciously realizing we've seen a snake. And this, for me, is very important. And there's a whole discussion about how there was this arms race between mammals and reptiles, arms race, evolutionary arms race in the brains, because obviously the reptiles were a major threat to mammals long time ago. And it's probably no coincidence that, you have the snake in the Garden of Eden, and you have dragons, which are a snake and a raptor and the big cat at the same time. So I think all these things have sort of filtered through to our cultures. So this just goes to show how much our reactions are not the result of conscious thought, the first reactions. And well, this is the relevant paper. It's been found first in other primates, in monkeys, but we seem to have it too. I'm not related to this paper, but it's exciting. So,
Sorry, just to clarify that
yeah,
that paper is the proof of snake detector thing in our head.
yeah.
Okay.
So, and there's a whole discussion about that. It's not just this paper. So, Immanuel Kant, when talking about beauty, thought that disinterestedness was a key to legitimate judgments of beauty. So, something doesn't have to be useful for us to find it beautiful. But apparently, I would say this is only true at the proximal level. Yeah, for us. But there is the issue of natural selection, identifying appropriate resources and shelters that would favor our survival as a species. There is aesthetic qualities of which you can judge fruit,
Mm-hmm.
if you should eat it or if you're poisoned by it.
Mm-hmm.
There's sexual selection, indicators that help select the best possible partner for reproduction. And it all filters down to our culture because I would argue that most people, men or women, gay or straight, would agree that Raquel Welch was beautiful. And, you know, none of the people looking at this image had any chance of procreating with Raquel Welch, even when she was alive. But, you know,
Okay.
we agree because it's formed part of our aesthetic criterion, this thing. And most people would agree that the snake is scary, although the chances of our dying by snake bite is quite low. So that forms, for me, part of our culture. There are other things. Infants are instantly attracted to a face, which is to be expected, because, okay, they have to be able to see what the other person is, the mother is, and within a week after birth, they spend more time looking at faces that adults judge as more beautiful.
Only one
Okay,
week after.
only 1 week after. I think that's fascinating.
It's fascinating because they don't see very well.
They don't
They
see very
see in
well,
black
but
and white.
they no, not really black and white, but no, this idea is old. They don't really see in black and white. I mean, it gets better and better vision, but it's not like they just switch from one system to the other.
Okay.
So there's so much for the, you know, socially constructed idea of beauty. I think there is social and personal modulation of the criteria. Certainly there is, but there is no social construction. For me, it's quite clear. Now, Dobzhansky, a very famous biologist, has said sensitivity to beauty and making or doing things that are perceived as beautiful are among the traits that elevate man above the brutes. And yet, look
I
at
love that.
this. Both humans and peacocks agree that this is beautiful.
Mm-hmm.
Okay?
Mm-hmm.
And peacocks agree because if they didn't agree, they wouldn't be selecting this. And they are actively selecting. The females are selecting for this pattern in males.
Mm-hmm.
This is something we often forget in evolution, that selection is not evolution is not just a bunch of random changes. It's random changes cultivated by selection, natural or sexual or whatever else. And sexual selection is is actually somebody pushing the species going in some direction. And look at these bowerbirds. They make these arrangements in their nests, and they even create forced perspective illusions. The male ones and then the female ones sort of fly over the nest and inspect, and if they approve of the architectural capacity of the male, they consider reproducing with him.
So
So
I
that's
see there are
yeah.
different ones here,
There are different
or
ones. Yeah, yeah.
and so it's kind of a style or a taste of each different bird,
I'm not
male
sure
bird.
if this is the case or if it has to do with what they have available,
Hmm.
but they're
Hmm.
definitely trying to create something. Yes, yeah. There's this gate, and then there's this colorful items arranged, you know, and in a non-random fashion. You can see maybe on the left, the ones on the left had only access to the blue, whatever it is, pieces of plastic. They even do it with plastic now because of the pollution,
Yeah, I
plastic
can
pollution.
imagine.
So, so the the sensation, the sense of beauty is something that has to do with survival in the end. Yes, it has to do with, well, you judge something. Well, you and the bowerbird and the peacock and everybody else in the animal kingdom judge something as beautiful. And I'm not saying they have the same concept as we do, because concept is something that happens post hoc.
Mm-hmm.
But they find something attractive, and they are, well, drawn to it.
Mm-hmm.
Now, you probably know about the biophilia hypothesis.
No, tell me
That,
about it.
well, it's the idea, and it's been around for decades, that humans have an innate affinity for other living organisms and generally the natural environment.
Mm-hmm.
And it makes sense because, well, we evolved in nature and as part of nature.
Mm-hmm.
And nature has certain geometrical qualities.
Mm-hmm.
Okay. And it seems that what constitutes this attractiveness is the presence of these qualities. And this is what we're going to discuss in a little bit. It seems that humans feel more comfortable in environments with the geometrical properties that are similar to ancestral human evolutionary
Mm-hmm.
environments. So identifying them and trying to introduce them in artificial environments could be very useful. Okay.
Mm-hmm.
Now, this can be done either as a conscious attempt in biophilic architecture, and I'll tell you why the inverted commas,
Mm-hmm.
but it also exists in pre-modern architecture as an intrinsic quality, either by virtue of the design or by virtue of the use of the materials, natural materials. Even the simplest vernacular buildings, because they have natural materials, they have this kind
Mm-hmm.
of part of this geometry incorporated. Think of timber, for example,
Mm-hmm.
the patterns in timber.
Can I ask,
Now, yes, please.
in the pre-modern architecture, when you say that there was biophilic or like living things, would Art Nouveau count? Because Art Nouveau is
Oh,
full of
yeah,
like,
definitely.
mhm.
Definitely, yeah. I know it. you can call it modern, but I mean pre-Bauhaus, that's what I
Yes,
mean.
yes, yes, yes.
Otherwise, historically speaking, yeah, it's modern, yeah, but I
No,
mean
no, I just was
pre-Bauhaus.
thinking the first that comes to mind is Art Nouveau, and then also Rococo.
Yeah, yeah, but not just those. These are the
Mm,
most obvious ones. I agree,
okay.
but just those. And I'll show you in a while what I
Okay.
mean. So in recent years, biophilic
Hmm.
buildings are basically buildings with a lot of greenery on
Hmm.
them.
Hmm.
I mean, look at the Bosco Verticale in Milan. It looks
Mm,
pretty because of the trees.
hmm.
If you remove the trees, it's just hideous. Okay,
Yeah.
so
Hmm.
um, so for me, ideally, biophilic architecture is the kind of architecture that incorporates uh, all the features of the organized complexity that we see in nature.
Mm,
It incorporates it in the building itself, and it does not use greenery as a band-aid. Greenery is wonderful. I wish all buildings have some green in their balconies, but it shouldn't be what saves them, you know,
hmm.
from looking ugly. So this was first approached systematically by Christopher Alexander, architect, and Nico Selinger, the architectural theorist and mathematician. Alexander is no longer with us, unfortunately. And Nikos approached these topics in a more sort of solid and quantitative way. Alexander in a somewhat perhaps more philosophical way, but his books are very, very interesting. Alexander's books,
Hmm.
and some of the things that he saw and described them in some way. Now we can see them in different ways and describe them more quantitatively. So
Hmm.
this organized complexity is made up of the presence of fractal features, a hierarchy of scales, the presence of local contrasts, and an overall coherence. And this is just an overall sort of summary of
Hmm.
these properties.
Hmm.
Talking about fractals, this is the classic question: how long is not the coast, the coast of Britain or any other country for that matter? And of course, it depends on the measuring stick.
Hmm.
Yes, um, we have we agree to use a reasonable level of resolution,
Hmm.
okay, to produce a map that's useful
Right.
and a metric that's not crazy.
Right.
But if you want to go all crazy, you can go around every pebble,
Yes, that's true.
you know. That is the reality of nature. The
Mm,
approximation is what we use to have, a practical result.
hmm.
And this, by the way, is true for all those shapes that the modernists consider primary and somewhat special. The plane, the line, the sphere, yeah, they're special in one sense. They don't exist.
In nature.
They're geometrical abstractions that help us do the job of calculating volumes and
Hmm.
surfaces and distances, but we have to remember that they don't exist in nature. Okay,
Hmm.
so if there's anything special about them, is that they don't exist. So these are the ones that we're least connected with neurologically because we've never seen them in our lives. Uh,
Let
you
me
know,
just recap that.
yes,
So,
please.
like a perfect box,
Yeah,
this is not or a perfect rectangle.
yeah,
These are things that are not in nature yet. If we look at postmodern, post World War II design, we will see a lot of boxes, perfect squares, perfect
absolutely.
rectangles. And you talked about a plane, like a flat plane. That's also something that doesn't necessarily exist in nature. And yet we have this minimalist design that everywhere is flat, flat, no texture, nothing. And then you also mentioned a perfect sphere that doesn't exist. And we have like all kinds of things that are round, but they're not a perfect sphere. And I know that you share my criticism towards hyperminimalism. And I'd love if you could just share a little bit about why that is neuroscientifically a thing.
Yeah, and gladly. Minimalism um, is exposing people to minimalism is the equivalent of sensory deprivation, basically. We know from humans and also from animal experiments that sensory deprivation is a bad thing. Okay. Um, on the flip side, sensory enrichment, even in mice when they grow up in experimental environments, is quantifiably beneficial for their brains because they're exposed to different shapes and they have to take the shapes in, and to take the shapes in, they have to cultivate the appropriate synapses. Now, talking about development, and then I'll come to the adult phase. In development, up until age, what, 2, 3,
Mm-hmm.
we keep producing an obscene number of synapses every day.
Mm-hmm.
Okay, so synapses are connections from
Mm-hmm.
one neuron to the other. And then the synaptic pruning starts. And pruning means you get rid of synapses that are not used and you keep and strengthen synapses that are used. So the kind of environment you're exposed to when you grow up plays a role in the end in the architecture, the microarchitecture of your brain.
Mm-hmm.
And this is true for everything. It's true for architecture, it's true for music.
Mm-hmm.
I have absolutely no doubt that, you know, if you are exposed to what we broadly call classical music when you grow up, it's actually better for your brain than if you're exposed to rap. I have no doubt about it as a
Mm-hmm.
neuroscientist. Um,
Could you just
and
qualify that a
everything.
bit and explain what the difference is between classical music and rap music?
Well, it's structural. It's
Mm-hmm.
structural, and not just I brought rap as the extreme example of almost well non-music, but
Mm-hmm.
it's structure, the complexity, the different melodic lines, the harmonic structure, um, how things evolve in time. It's not just a repetition every 2 minutes, or so it's structure, and it's exactly the same with buildings.
Mm-hmm.
Um, Now, this is the one thing. The other is, so for me, it is sensory deprivation, and we have data from all kinds of species, from mice to humans, everything that it's a bad thing
Mm-hmm.
in development. Now, even in adulthood, look, we feel safe when we are anchored in a way to the environment,
Mm-hmm.
and and I will come back to this a bit later. Um, the anchoring means that you see your surroundings, you feel comfortable with it,
Mm-hmm.
and because of that, you can perceive any potential danger coming to you very easily.
Yes.
So if I'm in the forest and I can easily grasp the image,
Mm-hmm.
I will see the big bad wolf coming to get me very easily. If I'm trying to decide what is what here and where does it start and where does it end, it's difficult on two levels. One is the psychological. It creates anxiety because you are not sure. You don't feel you have full control of your own position, let alone the plan to avoid the predator. And I'm not talking about. I'm not saying this is what you think about today. I'm saying this is what is sort of preset in your brain. And the other is there is actual metabolic difference.
Yeah.
It's been shown that some non-natural patterns. It's been shown as work of Wilkins and collaborators. Parallel lines of a certain distance are actually metabolically stressful for our brains. It's
When
more difficult. It takes more blood flow, more processing to perceive a bunch of parallel lines than a tree.
So it's not just metabolically difficult. When you say that to me, I hear metabolically costly. So
Yeah,
you're
yeah, yeah,
doing
yeah.
more, and therefore you're burning more calories to do so. You're not.
Yeah, 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 yeah. So it's stressful at a physiological level at the end. You're trying to decipher the structure that you're exposed to.
Hmm.
Because a bunch of parallel lines is not something we're tuned to. Yes, we can perceive it, but we're not tuned to automatically. We are
Hmm.
automatically tuned to the geometrical, to the
Hmm.
geometry of nature. You
Hmm.
know.
Great.
So there are these two levels, and
Hmm.
I mean there are other examples. Like think of a glass floor, for example. You know that uh, it's not going to break. You know this at the logical level. but it's stressful
Mm.
because you feel the stress is like, you know, when you're at the edge of a, if you go to the edge of a balcony with a low railing, first you see that you're in a falling off place, and then you think it's a balcony, you know. So this the same with the glass floor. You don't feel secure even though you know it is safe.
Right. Okay.
So some details about this geometry. So okay, this is another example. So you have this, you can make fractals very easily. You just put a formula with a generator, just turn left, right, do this, blah, blah, blah. This is a very easy one.
Mm-hmm.
And another one, and you can end up with a line like this.
Mm-hmm.
Okay, okay. So look at this. It's made up using this simple formula.
Right.
And then, well, this is the classical example. The leaf and the tree, they're self-similar on many levels. They're not
Mm.
exact copies. Okay,
No.
this is the geometrical fractal, which also doesn't exist in nature, but they're
Mm.
self-similar. And this looks very much like this. No, you know?
Mm-hmm.
Yeah,
Mm-hmm.
this one. Yeah, but actually, this is just the outline of this.
Hmm.
Okay, this is from Taylor's work. He's been working on Richard Taylor fractals for many years. Um, Also, this is basically just the outline of this.
Mm.
Okay, and this is why Persian carpets are so fascinating. You can just dive in, you know, yeah, the further in you look, the more detail you discover.
Mm-hmm. And they're
It is
popular
not,
all over the world.
of course there are. Yeah, yeah,
Mm-hmm.
yeah. Now this is related to what I was saying earlier. Um, this is um, there's this thing. Well, I have to go back a little bit. In the brain, there are what we call functional networks.
Mm-hmm.
It's areas of the brain that you see them sort of going up and down in activity together.
Mm-hmm.
So if they're going up and down together, it means they're doing something together. Okay.
Right.
One such network is the default mode network. In the past, they thought it was the task negative network. Now this is not considered like that anymore.
Mm-hmm.
But we know it's related to daydreaming, mind wandering, thinking about ourselves and others,
Mm-hmm.
remember the past and the future. So it's not something that you use when you're trying to solve a problem. Okay.
Okay.
It is, you are in a more relaxed state. And
Mm.
look, fractal structures are perceived just by using the default mode network.
Mm. You don't have
So
to engage your brain hard, basically, is
you
what you're
don't have
saying.
yeah, you don't have to like solve the problem.
Mm.
It comes as naturally as doing introspection, you know. It's not that you're not doing anything. You're doing something, but it's something that is not um, it's not
It,
problem solving.
it's within the range of activity of the default mode network, is what you're saying.
Yeah, yeah, yeah. It's not a problem to solve. It's something that that sort of comes easily to you. So this is very interesting work from Anna Franklin's lab
Mm-hmm.
a couple of years ago,
Mm-hmm.
showing basically that the geometric properties of images that are associated with preference in adults is also associated with are also associated with preference in infants.
Hmm. So no
So
difference in like
so
experience in life or anything like that.
yes, and these of course if you use this metrics, the edge
Mm.
orientation entropy is, you know, how the edges of the orientate. Well, you extract the edges from a photograph, and you see how much the edges that are present in the photograph are in the same direction or many different directions, or you know, it's a measure of complexity. It's not
Mm-hmm.
the same as fractality; it's another measure of complexity. So
Mm.
obviously, pre-modern buildings are the ones that rank higher in this
Hmm.
metric. So this is, for me, a newfound basis for once self-evident forgotten truths.
Yeah.
Um, because somebody might say, well, okay, everybody knows that we like nature and everybody knows that most people, with exceptions of those who studied architecture in the last several decades, don't like post-World War II buildings. Yeah, but the problem is that the members of the public who dared to say these things were met by the architects with responses like, "Well, you do this because you don't know." But you don't have to know. It's like if you're going to a restaurant and the food they bring you is disgusting, and you ask to speak with the chef. If the chef comes and says, "But you have not studied cooking, you cannot talk about these things." Yeah,
Great
but I'm eating
analogy.
it. I'm eating it. Thank you. And we are force-fed these
Yes.
things because they are the facades of the streets of the cities we live in.
Yeah. Yeah.
So it's not a private matter. It's not just for the experts.
Hmm.
They can go and write essays, or they can make, exhibitions, and they can go and congratulate each other in those exhibitions. But for the average person, that's it's a matter um, of mental and even physical health. Because I said physical health because all this is connected with stress, as I said earlier. Yes. Um, and since we made the connection of the geometry of nature with the geometry of buildings, and this is now established, it's not just a wild hypothesis, there are many, many studies that have shown the actual mental and physical benefit from exposure to nature. Okay. Um,
And
and
could
the,
you just explain a little bit what you mean when you say the mental and physical benefit of nature?
well, the most sort of well-known, perhaps, and classic study is one from the 80s, where they compared patients, post-surgical, post-operative surgical patients, um, whose only difference, they divide them in two groups, and the only difference between the groups was the view from the window they had in the room.
Hmm.
It was a view of trees or a view of a blank wall. Well, viewing trees actually accelerated postoperative recovery.
Yeah, I've
And
read that one.
this is
I
very
believe
well
it.
known. And there's a bunch of other metrics regarding mental health, many, many things. Um,
Hmm.
Stress, people have measured stress, um, even on site. Uh, Volunteers walking from one part of a town to another,
Hmm.
and
Hmm.
in the ugly part of town, they feel most stressed.
Hmm.
So there's a lot of evidence accumulated in the last uh, number of years, maybe even 20, I would say, but in the last 10 years, even more
Hmm.
in this direction. Um, Now, there is this, well, this paper on the right is from 2013 and is my first sort of uh, endeavor in this field.
Hmm.
Um, and I have to say, there is this series of lectures by Leonard Bernstein, the composer and conductor at Harvard. It's also all on YouTube. It's about 12 hours. If you're
Hmm.
interested in music, it's like
Hmm.
some of the best 12 hours you'll spend. And he makes, he was also not a modernist in the
Hmm.
sense that in his compositions, you can tell they're contemporary, but they're always okay. They're not atonal, they're not 12 tone, they're
Hmm.
tonal. Many modern composers didn't like him for that. And he believed that tonality was, he called it the roots on the ground of any kind of music that has some kind of affective contact with the listener that
Hmm.
can get a connection. Otherwise, it's just a purely intellectual construct. And I remember listening to this talks in this is so relevant to architecture. It's amazing. He made a parallel between music and language, and you know that Chomsky had proposed that there is a common deep structure in all languages, and what you get in the different languages is what he called a different surface structure. So Bernstein was saying that as long as you are rooted in the common ground of tonality, you can produce an infinite number of novel musical works, but without breaking that base, which is what connects you, the composer, to the listener. Okay.
So just to understand, how does he define tonality? in these series, the 12-hour one?
No, tonality is just in the conventional use. It exists in music theory, that you have a series of tones, and you have a resolution. It's just the conventional the conventional use of the word, as opposed to, for example, 12-tone music, where you have to expose all 12 tones. If you look at the piano keyboard, you look at the blacks and the whites are 12. From C to C, they're 12. So 12-tone music is interesting intellectually, but it's difficult to connect with it on an affective level unless you are a trained musician who has an intellectual interest in it. And my thought was that this is exactly the same with architecture and design, that there is this common deep structure that we all share, that all pre-modern architectures and design styles share throughout the world, which is based on this ground of the geometry of nature. And then you have the different expressions, which are the surface level. And, a neoclassical building and a Persian building have different surface structure, but they have this common deep structure. And this is why they're both likable, no matter if you were born in Greece or Italy or Iran or India. And what I had written at the time, and I still believe it, is that we can treat these rules as visual syntax rules. And they do not lead to predetermined results, because some people say you're going to do the same again and again. No. Using the tonal system, which means the way that people wrote music up until the beginning of the 20th century, doesn't stop you from composing an infinite number of new compositions, or keeping the grammar and the syntax of the English language does not stop you from producing potentially infinite number of new works of literature. You don't have to break the grammar and the syntax to produce new literature. I think that modern architecture and also modern music, I mean, when I say modern music, I don't mean pop music. I mean, Schoenberg and things like that. They do that. They break the language. Now, a little experiment. So this is just a piece of plasticine, okay? Repeat it with Photoshop in different ways. Which one do you think makes sense, makes more sense? And
I like number 12.
Yes, of course, I agree with you, and so do most other people. This is an experiment about the hierarchy of scales.
Okay.
So you have one big thing, and 2 smaller things, and 4 slightly smaller things, and 8 even smaller things, and 16 even smaller things. And that is hierarchy of scales. And these are the results of the ranking. It should be a bar graph, but if it was a bar, it would be like a big mess. Whereas with this continuous line, you see it much better. So 12 is the one that makes more sense and looks prettier according to all. And the worst ones are the ones that have like big scale jumps, like 6, for example, or 8. Quite hideous. But this is what you see in modern architecture. You have a big building, and then you have these windows with barely, I mean, sometimes not even a line, just openings.
Yes.
There's no scale at the scale level, and then you have the openings, perhaps. So that was a simple survey. So this was then, the idea was expanded to this paper, which was basically showing people various images and asking for their feedback. And C and D are fractals. Okay? But D is a fractal, and these are all geometrical fractals, so the ones you don't find in nature. And these are obviously computer graphics, not pretending to be anything else. Okay, so I took a picture of a village in the Alps, and I just stuck some computer graphics on it, and And B is not fractal, but it looks actually a little bit like a modern building more than the others do. So
Right.
if somebody would think that one of them is a building, it would be B. And
Hmm.
yet look at the results.
Yes,
People
2C
prefer
is more
A,
attractive to me.
yeah, and people prefer A and C in general
Yeah.
because these are the fractals of the correct um, fractal dimension, as we call it. Even
Hmm.
though they don't exist in nature, they have the correct fractal dimension. D is completely unnatural. B
Hmm.
doesn't exist.
Hmm.
And I found this also quite interesting. The differences between the two images are not dramatic, are they? They're not dramatic.
No.
They're not huge. But look at the scores.
Yeah, massive.
You know what the differences are. In B, I went there with Photoshop and I replaced the bigger rocks with smaller rocks the same size as everything, as all the others. So in the natural image, you have one big rock and two, three smaller ones and more smaller
Hmm.
ones. In B, you have just the smaller ones, have
Hmm.
one scale level.
Hmm.
And this is so unnatural.
Yes.
Even
I mean,
though the differences are small, people prefer it with so much, so dramatically, you know? I find this fascinating. Something else I want to show you. There is this, there's software trained
hmm.
by AI,
Hmm.
which does simulations of eye tracking.
Hmm.
Okay, so without actual participants, you can simulate eye tracking. So this is the Duomo in Milano, and in A, and B, C, and D are simplified versions. B, all the details have been replaced by the inverted image of of an office building. I
Hmm.
inverted it and then made the color as similar as I could to the actual building.
Hmm.
And in C, there is one extra line missing per floor, and in D, the whole thing is replaced by a cube. And
Hmm.
it's interesting to see how the gaze map shifts from the building to the people more and more and more.
Yeah. You can
Okay.
see in the first one, their gaze is on the windows primarily,
Yeah, yeah,
and
yeah.
kind of that structure of bigger opening, let's say, and then smaller and smaller. And
Yeah,
then
yeah, yeah.
after, you're right, it goes towards the gaze shifting towards just people in the plaza.
Yeah, yeah. And this one in Manchester, the building on the right, it's as if it doesn't exist.
Yes.
But
Yes.
the clouds exist because they have this fractal outline. Yes.
Mm.
And the Persian mural,
Oh, wow. The gaze is very strong.
the closer you go. Yes, and it does not dissolve because there are cases where I don't have all the pictures here, but with modern buildings, even if you have a coverage in the beginning, as you go closer, the thing completely dissolves because there's nothing to see. There's
Yeah.
one
Yeah.
line here, gap. One line there, gap. You can say, okay, but this is just gaze. How do you know it's related to preference?
Right.
Well, we know because of everything else we discussed, and there's more.
Mm.
There was this study from 2020
Hmm.
done by the National Civic Arts Society that showed that Americans preferred classical architecture to modern for federal buildings with this kind of proportion.
Right.
And although it's become a political issue in the States, it shouldn't have become because this is true for Republicans, Democrats, all ethnic groups, men and women.
Hmm.
So just everybody
Yeah.
prefers almost 70%. Um, so the National Civic Arts Society and its president Justin Shubo gave us the images, and we ran an actual eye tracking study. This is not simulated; it's actual
Yeah.
eye tracking with
Yeah.
participants, and of course the results are what you expected. There's more time spent on the classical building, and there is a faster time to first fixation. You know, a shorter time to first fixation. So you
Uh,
spot it first usually, and you spend more time on it.
and then you would probably say that if you were to bring this research to architects today, they would tell you that everyone doesn't understand.
Yeah, yeah, yeah. The same as with the disgusting food. You haven't studied cooking. How dare you? So, and then there's one more study that was published a few days ago.
Mm-hmm.
Same same stimuli,
Yeah.
but this time not looking at eye tracking, but looking at micro expressions.
Okay.
Um, these are very well established techniques based on the work of Paul Ekman. He
Oh,
died last year.
yes.
Um, it started with electromyographs, but now it can be done with a camera, even with a webcam.
Oh,
So people
very
are
easy.
looking at uh, these images, and the webcam just records their face. And if you look at
Mm-hmm.
the videos, you can hardly see any change in expression, but it does it.
Yes.
And so look at this video. So at the top you have engagement, and at the bottom you have joy. Okay,
Hmm.
so this building appears, and then this building appears,
And then you see there's some engagement there
and
and
it
joy,
keeps going up, and then this appears.
and it's flatlining.
Yeah, undecided here.
So now I know a different
Exa-
building is coming up because I could see it
Yeah,
starting to become
exactly.
more
Yeah,
interesting.
exactly. And then it's going down. The engagement is more responsive than the joy, but they're both quite interesting.
Yeah, the joy really plummeted on that one right there.
And then they both go high up on
Yep,
this.
very interesting.
So this was published just a few days ago. We did this with the Happy in Massachusetts.
Very nice.
So, and of course, blank screen is very disappointing, so it all goes down. And a last thing, if you go to text to image AI
Yeah.
and you say, please produce an image of a beautiful building, you get something like what's at the top. And if you say, produce an image of an ugly building, you get what's at the bottom row.
Ah,
And this is
interesting.
consistent. And this is consistent. And for me, this is like a huge pull because this, AI systems see a lot of information from the net.
Right.
So it's like a poll, and many of the buildings are not successfully rendered, of course, because
Yeah.
they're not it's not professional software.
Right.
Sometimes they're pastiche, sometimes they're just impossible to do, and these are
Yeah.
like a couple of years old. They're getting
Hmm.
better now, but it's an indication, I think, of what people really like. It's like a huge scale survey, and I think that dismissing what people feel comfortable with because they haven't studied architecture, I think is a big mistake. Um,
Well, I
on
can
every
imagine.
conceivable level, from the health level to even the level of actual democracy, I would say.
I mean, if you think about the AI example, it's pulling from data from online. And when people say, oh, go
Exactly,
visit this city, check out this building, I don't think I've never seen in the top attractions, go look at this building that's a rectangle with other small
exactly,
rectangles. Like,
exactly, exactly. And it's what I was saying. This is basically giving people their voice back.
hmm,
And it's not, I know that a potential objection would be that this is too reductionist and you can never quantify the individual experience. Well, this is not supposed to take the place of architectural critique or architecture. It's supposed to quantify what is quantifiable. The human experience is very, very complicated. And of course, uh, Roger Scruton, a late philosopher, said he was against neuroaesthetics. And I think I wish I would have talked to him because he meant well, but he was wrong about that. He was saying we live on the surface and it doesn't matter what's under the hood. And it does not matter if on this level, on the level of on the conceptual level of what aesthetics is, but it matters in the sense that it helps you understand, well, A, it's scientifically interesting, whatever it is that's happening under the hood, and B, it helps you, it
hmm,
gives you arguments when you're trying to defend exactly the non-specialist against the so-called specialist. And I'm saying so-called because their paradigm of how humans function is at least 100 years out of date.
Hmm.
They think that all we need is air and water and light, and of course we need all that, but we need much more. You see.
Wow, I'm so grateful for the work that you're doing, pushing this forward, and I would love to see less buildings that are just a clean rectangle with a clean few boxes in it.
Fingers
And
crossed.
yeah, well, your work is helping show that. I mean, I think it's intuitive. I think anybody who listens will find that intuitive, and I hope that policymakers will be able to see this, and that we can start seeing more new buildings, modern buildings, but with our health and neuroscience in mind. So thank you so much for taking the time to explain your research and why it matters.
Thank you so much for the invitation. It was a pleasure for me.